Okay, welcome to the next video in the Pinball 2.0 kit. This is going to be just a one-off video where we're going to talk just about the spinners. And there's two spinners on this playfield, and these are the old school Bally style. And so basically you have a lane with a post on each side and a sort of gate that goes across here. And you hit the spinner here, and there's a linkage that goes on this bar that goes down to a switch, a leaf switch on the underside. All right, now the issue that I found with this is that it's hard to find a quality reproduction complete spinner assembly. You can find individual parts. It's hard to find a complete assembly, and it's also, for a homebrew person doing a kit, it is a little bit difficult to get the adjustment right of the wire length and the leaf spring adjustment and everything else. So this is actually an opportunity to come up with a new design for those that want it. All right, so we're going to try and create a different solution for this, a more modern solution. The problem is the modern solutions available, they're usually this type of single bracket that's open on this end, but you'll notice that on modern games sometimes the target is actually smaller, about a 1/4 inch smaller than the normal target, and that's probably because the lanes, the shots are a little bit tighter, and so it's actually not going to span that full gate. And then even when you do find one that is the full width, this is the correct width, you still have this issue where this is not going to be able to sit in the same spot as this one. Like if we put this one here, this can't sit in the same spot because this bracket is going to be in the way here. All right, so I'm going to try and do something a little bit different. It's going to be similar to this. We're going to try to use this target that you can get, and this one is actually made, there's a little micro switch that sits here, and every time this spins it hits that switch. One other issue you can see is that this, even if we could mount this bracket kind of sticks out and it's somewhat exposed, could take hits if balls are coming down this way. This other bracket is also interesting. It's got a little bit of a different bend here, but this one is meant for an opto to go right there. All right, so the opto would sit like this, and then every time you hit the spinner, this bar here would break that opto. All right. The problem you see with this one is that the opto, this bar is specifically bent this way, so the opto can sit up and down. The problem with this one is that the bar is straight, and so this opto would have to sit like this. All right, so the goal is to try to create a solution that gives us, that spans the two posts like this, old school, but will allow us to use a larger target, and then ideally with an opto. All right, so I've done a couple of iterations on this, and this is what I've come up with so far. And essentially this is a similar gate bracket that spans these two posts, and it has an additional bracket here for this opto to mount. And you'll notice that there's a little bit of extra flange here to actually protect this opto from any fly balls that would go this way. But also you notice that this is actually way below where a ball would be hitting. All right, but if you did get a fly ball, it would hit here and not the actual opto. All right, so this is the design that we're gonna try, and it's going to use the spinner that would normally have a micro switch, but again, because this this is straight here, not bent, what it means is that it's going to trigger the opto when it's horizontal instead of vertical. All right, so that actually works in our favor because we actually want this to be horizontal. One other advantage of this design is that it's symmetric, so it would work this way or this way, and the spinner itself is symmetric, whereas some of these other versions, they would actually have to be left or right. They don't work like in this case with the switch. This only works really when the switch is pointed to the back, so that if you had this on the other side, you'd need a different bracket that was bent differently for this. All right, but in our case, this is symmetric, so we only need one design. Okay, before I assemble this all together, I want to put the stickers on the actual metal spinner piece. All right, so we're going to do that first. All right, before we assemble these, we're going to put the stickers on, and we want to make sure that the adhesive sticks. We're going to want to just wipe it down with some isopropyl. Get that surface clean, any oils that might be on there. And this one will be the left, and so the front of this this bar here is to break the IR beam. So this will be the front, and the other one is reversed, so the bar will be on this side. All right, and be careful. I'll put the right part number in here, but be careful. These come in two different flavors, and they're not exactly the same size. But I'll make sure we put the part number in there because we want the one that's a little bit wider. All right, let's put the sticker on. These are vinyl stickers. You want to be very careful when you stick these on here. Get them square. They're almost exactly the same size as the metal, so there's very little room for overlap. If you put it on and you decide you didn't get it correct, you could very carefully use an X-Acto knife to sort of get the edge and then peel it back up. But your mileage may vary with that, but I would recommend try to get it as close as possible the first time. All right, and what I'm going to do is, instead of having just a 1 and a 1, I'm going to use this different sticker from Atari Space Rider. And the idea is that this mode is that the spinner basically bumps up the RPMs of your engine to get you ready for a jump. And so I think it's going to be more interesting if every time you hit this, it went to a motorcycle graphic. The key is that this is going to be flipped. So when you put this on, you got to flip it and put it on this way. All right, same thing. Just be very careful when you put this on. Make sure it's square. Okay. All right, that looks pretty good. All right, and the idea is that this is a 1, and then when you spin it, it's like that. Now when you look at it this way, it's upside down. All right, so you want to make sure you flip it. All right, that's the left one. Now we're going to do the same for the right, but make sure it's mirrored like this. Okay, so our holes are tapped. We're not going to put this on just yet. We're going to install the spinner first. Tapping it to just makes it a little bit easier because we don't have extra pieces on there. All right, so what you want to do is you want to take the longer end and work it through the side where the bracket is. You're going to have to sort of like twist it and turn it to get through like that. Now on this side, I have a much shorter one. You're just going to have to bend this back slightly. Try not to bend it too much because you're just trying to like a spring, just try and open it up just enough to get that in there. And then you may have to squeeze it to get it back. All right, and now you should have your spinner like that. Okay, all right. Now we'll put on the opto. Okay, so we have our opto. We have some really tiny short 440s. Looks like 3/16. All right, and you just set this, line it with those holes. Put the screw in here. All right, so yeah, so 3/16 is flush with that. Okay. All right. This is plastic, so I wouldn't tighten it down too much, but you just want it snug. Okay. All right, so let's put this on the playfield. And you notice I've cut the connector on this because we're going to put our own connector on here. And this actually has to go to an opto driver board for this to work as a switch. And you'll notice also that this bar breaks that little hole there where the sensor is. It's going to break it twice, but you can fix that in software. Every turn it'll break it twice. All right, let's put it on the playfield. Okay, we're going to run the wire through this hole. This is where the linkage would be normally. I'm also going to put another one of these mini posts into this hole here, because that's actually going to help protect it when if balls happen to come back this way. Is meant to protect the linkage, but in this case it'll be protecting the wire. So just run our wire through that hole to the back side, and then we put our thing on the post here. All right, I'm going to move around to the other side. Okay, and now we put our acorns on. And tighten that up. Okay. All right, you probably just hand tighten these for now. It's pretty snug. Okay. And yeah. All right, let's give this a try from the other side here. Okay, so the ball comes through here. I'm just going to catch it. All right, very good. And with no friction and no force coming from the spring, the leaf switch, we get quite a few turns just for a relatively easy hit. All right, so we'll get some really good rips on that. Oops. Get some really good rips on that. Okay. All right, let me show you how this wires up. Okay, I put together this little bench top circuit in a breadboard. If I put 5 volts here, you see my little red LED comes on to indicate I have 5 volts. The wires for this opto, if you're familiar with an opto, you can't just put 5 volts to the opto. The opto has, the transmitter is an infrared LED, and the receiver is receives infrared. It's an infrared transistor. So what we need to do is we need to current limit the LED. The LED is a current device, not a voltage device. So what we have here simply is just a dropping resistor that takes the 5 volts, drops it down to the voltage of the IR, which is about 2 volts, but it drops it to like roughly 30 milliamps. So this is about a 100 ohm resistor. All right, now in the real game, there's going to be a circuit board that will either do this or it will be a current driver for your optos. All right, so you won't be using this, but there'll be some board that you'll plug into that will do that. All right, since this is for demonstration purposes, I've also the output is a like I said, it's an infrared sensitive transistor that basically it'll sort of through solid state it will open and close the switch. To make this more visible, what I've done is I basically added another transistor that will turn this this green LED on and off as it's breaking the beam. That gives us a more positive indication of what's going on. And so if I hold this here, all right, so every time this little bar crosses that beam, the light turns on and then off, on, off. So it's actually going to trigger twice. Every rotation is going to trigger twice, and so that's something that we'll have to account for in the software. All right, let's put this on the playfield and see how it works. I've mounted the spinner to the playfield. Let's look at it from this side. I've also got our little circuit here so we can see it, and so like every time this rotates, breaks the beam, the light will turn on. All right, so we're going to look at this as we move this ball. I'm just going to throw it through manually. And we get some blinky lights here. That's good. All right, so every time that light turns on, it's going to be activating the switch. All right, and again, we get one closure there, one closure there. So in software, we'll do the math to cut that down by a factor of 2. All right, that's going to be the end of this video about spinners. And again, this little circuit will be something that we'll try to get off the shelf for the kit. You can get something like this from Fast Hardware. All right, stay tuned for the next video, and thank you for watching.